In this video, we'll be doing more proofs of triangle congruence. So before we looked at how to prove a triangle is congruent through knowing that all three sides are congruent to all three sides of another triangle. We can also do congruence proof through side, angle, side, which means basically that two sides of one triangle are congruent to two sides of another, as well as the included angle, so the angle in between those two sides. And that's what we're going to focus on today. Later on we'll do some more proofs, but this one is the one we'll focus on today. And just in case you are curious, the other proofs that we can get to and will get to are angle, side, angle, being congruent to angle, side, angle, and finally angle, angle, side, being congruent to angle, angle, side. All right, so all of this will become clear when you see an example for each one, and we will focus on that one today. Okay, so let's try a two-column proof that involves the side, angle, side postulate. All right, so in this example, we are actually being asked to prove that two angles, this angle CFD and CEB, are congruent to each other. So we're asked to prove that, so I'm going to use a different color to mark those angles because we don't fully know that unless we've proved it. So we have CFD here, and we have angle CEB over here. So those are the two that we're being asked to prove. Now remember that when you're doing your two-column proof, you always want to start off with information that is given. So let's go ahead and put a column for our statement and another column for our reason. And remember that we always, again, want to start off with our given information. So we know given here that BC is congruent to DC. We also know that BCF is congruent to angle DCE, and we also know that side FC is congruent to side EC. These things are not only given up here, they're also marked in our diagram down here. So that's congruent to that, that's congruent to that, and this angle is congruent to this angle. So all of that information is given. So we could have broken it up into three given pieces of information, or we can lump it together like this. It doesn't really matter that much. All right, so from that we can keep going here. And we know that when we have, according to our side angle side postulate, if we have two sides and the angle in between congruent to two sides and the angle in between, that is enough to tell us that our triangles are actually congruent. So that is the next thing that we know and we can support. And that is that triangle BCF is congruent to triangle DCE. And that, again, the reason for that is because of the side angle side postulate. And we don't have to write side angle side postulate. We can just write SAS for short. All right, so now we know that those two triangles are congruent to each other. Now the next thing that we may know is that if two triangles are congruent to each other, then the parts of those triangles are congruent to each other as well, which means that if we take that angle here, it's going to be congruent to that angle here because they're part of two congruent triangles. They're the corresponding parts of two triangles. That is called something that shows up in proofs all the time, congruent parts of congruent triangles. I just made a mistake. It's not congruent. Corresponding parts of congruent triangles are congruent. And I'll write that down. Okay, so we have here for the third statement that angle BFC is congruent to angle DEC. And the reason for that is that corresponding parts of congruent triangles are congruent. For short, it's called CPCTC. But I'll write it down just to make sure that you remember this. I'll write it on the side. CPCTC just means corresponding. Oops, my pen is not working. Okay, there we go. Corresponding parts of congruent triangles are congruent. And that makes sense, I think. All right. So once we know that those two angles, the ones I marked in blue here and here, are congruent, that's going to help us out a lot in our proof. Here's why. Well, if that is here and that is here, that's actually a linear pair. So is this. These two angles are a linear pair and these two angles are a linear pair. And if you recall, linear pairs are supplementary. So we can now state that, and this is our fourth thing here, we can now state that angle CFD is supplementary, so let's just say, and angle CFB are supplementary. I'm just going to put sup for short, but that just means supplementary. Also, angle CEB and angle CED are also supplementary. And the reason that we know they're supplementary angle is because we know the definition of a linear pair. So by supplementary, I mean that the measures add up to 180 degrees. Hopefully you know that, but if you didn't, now you do. So definition of a linear pair is why we can say that. All right, so we're almost there. Now you may recall from an earlier step that angle BFC and angle DEC are congruent angles. Now, check it out. We have BFC right here. I just wrote it in a different order. And we have DEC right here. Again, I wrote it in a different order. But these two angles are, in essence, the same. They're congruent angles. And so according to the congruent supplements theorem, so I'll actually write the reason down first here. According to the congruence supplement theorem, if we have two angles, so in this case we have two angles that are supplementary with congruent angles, then these two angles have to be congruent to each other. I will repeat. We have two angles here that are supplementary with these two angles, which are in essence the same. So because they're supplementary to the same angle, then these angles must be congruent to each other. And so for that reason, step 5 here, angle CFD is congruent to angle CEB. So that's the B. All right, so that's our proof. That's what we were trying to prove initially, and that's what we ended up getting at the end. And so we are done.